Okay, so we're going to identify the major species in a weak acid or weak base equilibrium. And what's going to happen in these cases, and I'm going to slide right down to here, is that what they're going to do is they're going to add a strong acid to a strong base here, and then they're going to add a strong acid to actually a buffer. Now, we won't have to do these strong acid to a buffer. This part here will not be done on the AP exam, but I want to show you how to do that as well because it's not that much more challenging. What we need to be aware of, though, when we're doing problems like this is what is actually reacting and how much of each is reacting. So if we take a look at this right here, we have 1.1 moles of HNO3. Now, if we take a look to what we're adding it to, we have 1.1 molar and 1 liter. And remember, if we multiply molarity by volume, we end up with moles, right? So if we were to take these two numbers right here and we would just multiply the 1.1 by 1 liter, I'm pretty sure that gives us 1.1 mole of our NH3 as well. So when we're taking a look at our reaction, what we actually have going on here is this. We have HNO3. Now, normally what I would do, and this is anytime you have a strong acid being added to a base or a strong base being added to strong acid, there's always two steps to your problem. One is do the stoichiometry first, and then two is take care of the equilibrium. In this case right now, and when I do that, I ignore the NO3 part of this, and I just write it as H plus is going to interact with NH3. And that's how I do it every single time. But in this particular case, they're asking what acids are left, what bases are left, and what others. And what they really mean by what others is, are there any spectator ions that are being included in here? So let's delete that so we don't want it. So we're going to keep this in here, the NO3, knowing that it's going to be gotten rid of on the other side. So we're going to have NH3, and it's going to react, and it's going to form NH4 plus and NO3 minus. Now, this is all aqueous, and so what we do know that is happening here is that this, and I don't want to put a line through it because we have to actually include it. This and this are doing nothing in our reaction. But what we know we have is we have initially, and I'm going to do initial change and final, we have 1.1 mole of this, and we have 1.1 mole of this, and we have none of this to start off with. So what's our change when the strong acid reacts with the NH3? We're going to lose 1.1. It's going to completely use itself up, 1.1, and we're going to gain 1.1 millimole of this. We're going to end up with no H plus, no NH3 plus, and here we're going to have 1.1 moles. Now, in theory, what we have here is it's also going to form 1.1 moles of NO3 minus, but again, that's a spectator ion, but in this case, it actually matters. So what do we have left over here? Do we have any of our NH3 left over? Nope. So we have none of the base left over at all, right? We have none of our strong acid left over. We do have NH4 plus. In fact, that's the number one thing we have over here is NH4 plus. So for our acid, we have NH4 plus. How about our bases? Well, the only base that we had to start off with, wasn't it this guy over here, the NH3? And we have none of it. So we have 0 bases right here. So we're going to not have any of that. But then what other things do we have? And this is where they're asking about spectator ions. You see we have NO3 minus and NO3 minus. It's just sitting in there. So we need to acknowledge that NO3 minus is in here. If we were doing on the AP exam, they'd ask what are the major species involved, or what is the major species we have at this point. This, by the way, is the equivalence point of this titration. This is what this is called. All we'd have left is NH4 plus. And then if we wanted to figure out the pH, we'd have to take this NH4 plus in our second step and throw it into water. So that's the first problem. Let's take a look at the second problem here. In this case here, we have 0.03 moles of HI, and now we have 0.03 moles of NH3, and we have 0.03 moles of NH4Cl. Now, I'm going to do this really quickly and I'm going to actually just erase what we have right here. So I'm going to erase, whoops, that's not an eraser even by any standard, but it's fun. I'm going to erase all of this right here. And what we are going to start off with is a common ion. So instead of starting off with, and I'm going to do the math for you here, because if you have, if we take 0.03 moles of this and we multiply 0.3 by the 1, we're going to have 0.03 of both these. So we're going to have 0.03 of this, we're going to have 0.03 of this, and we're going to have 0.03 of this. Now, what is actually going to be reacting here? Well, this is going to completely use itself up with the base. And by the way, it's not HNO3 anymore, it's HI. And over here, so there is a little more erasing. I kind of got a, boy, I love that there. We're going to have HI, same deal exactly of what we just dealt with a second ago. And you may look at this and go, wait, that's an NH4Cl. It doesn't matter. NH4Cl is the same thing as NH4 plus. Now there is going to be, since we had NH4Cl, we have to worry about the fact that that Cl is still going to be floating around in here somewhere doing nothing. It's a spectator ion, but when we go to the other, we're going to have to put it in here as well. So we're going to subtract 0.03 here, 0.03 here, and we're going to add 0.03 right here. So what do we have at equilibrium? Well, we have none of the strong acid. We have none of the base. So just like we did before, we don't have any of the strong acid or the strong base. Now let's take a look over here at this. So we do have a weak acid, right? And then we have some spectators. So if we're taking a look at what do we have at the equilibrium right now? Well, since the NH3 stepped up here to react, again, we have NH4 plus here. We have none of the base, because this right here is a 0 mark. I tried to make it a square. And we have I minus and we have Cl minus as our others. All right, hopefully this has been helpful. I'll see you in the next one.